has gotten shoved out there. So we're still working on finishing the office, which isn't going to happen over spring break, unfortunately. Because my husband gets to work. So, but yeah, I was thinking about going up to Diamond Valley Lake because I want to see the wildflowers and going hiking. Maybe, we'll see. We'll see. We definitely get to go see the zoo animals. So I'll tell you, we'll have to take some pictures of the little boys reacting to the zoo animals for the first time because they've never seen them. So we've been talking to them a lot about seeing a real lion. So that's hopefully the lions will be awake when we're there. All right, you guys, let's get going. We're working through example 3. Depending upon time, I might skip around a bit. Okay, I want to get you enough of this so you understand it, but we might not do every single example, just because that way you have a little bit of each type of problem, and some of the problems are doubled up. Okay, and I know we did this ones like this the other day. I'm going to start here so that we kind of make sure we're refreshed and we know where we're going with this, and then can get the rest of it hopefully done. Okay, so what we did last time was we talked about top minus bottom. Okay, so in this picture it looks like my top one is kind of a blue color and my bottom one is kind of a red color, so we're going to go with that for our top minus bottom. And look at this, they gave us the picture, that was good, but we have to identify which one is actually the top and which one is actually the bottom. So is the y equals x squared minus x minus 2? So is this first one here, is this the top equation or the bottom equation? Can you guys tell me in the chat? What is that, the top equation or the bottom? All right, you guys are awesome. You understand that that's a parabola for sure, okay? And that's about what we have to know about parent graphs, is what they sort of look like. So that way, if we had to do a quick sketch with our basic shape, right? So we know if we see something squared, it's got to have that U shape to it. We don't have to be specific about it has to be graphed in this exact spot, okay? That's beyond where, you know, that was algebra 2, right? Not calculus. All right, and then, so that's going to be our red equation. And our blue equation is going to be this y plus 6. So we're going to find the area of region R. I'm going to work up in this blank area. Oh, actually, I'm not going to work up there yet. I'm going to save something else for up there. All right, so we're going to start our integration process. Notice this is a non-calculator problem. I know I did assign a few non-calculators the other day, so we'll go through one non-calculator here. We know we've got to use our top function, which is the blue one. So I've got to do x plus 6, and then I've got to subtract the red one, which is the x squared minus x minus 2. Hopefully you're noticing that those parentheses around that are very important because that negative means I have to distribute it through. And then there's a dx at the end. But I'm missing something because this has to be a definite integral, okay? The 8.1a is the second half of today's lesson. So I think I have that up there as today's video. All right. So I think I'll double check it in a few minutes here, but before, maybe as I make the transition between classes. Okay. But it should be there. I just put it up not too long ago, like half an hour, 45 minutes ago. Okay. Yes, it does matter which equation is first. It's always your top equation minus your bottom equation. Okay. If you get it in the wrong order, your signs are going to be off. All right. So that's a really good question, Mason. So it's always top minus bottom. All right. Okay. So we are going to, what we're missing though is our bounds on our integral, right? So I have to figure that out. And that's where these guys here, we were cheating using our calculator before, right? Because the problems were complex. Well, this one's easy and this is no calculator. So what I have to do is I have to set my equations equal to each other and solve that. So that's what I'm going to put in this space up here. So x squared minus x minus 2 equals x plus 6. All right, it's a quadratic. We're going to get it equal to 0, right? That's what we do with quadratics. So I'm going to subtract the x over to the other side. So we have x squared minus 2x. I'm going to subtract the 6 minus 8 equals 0. All right, good old magic x. We haven't seen one in a while, right? Can you guys help me out? What two numbers multiply to -8 and add to -2? Been a while, hasn't it? All right, -4 and 2. X minus 4x plus 2, which means I set them both equal to 0. My final answers on these should be +4 and -2. Your negative one is always going to go on the bottom. You don't even need to worry about the order there. It's always the smaller one goes on the bottom. Okay. All right, so let's go ahead and do the algebra and the integration to solve that. All right, so we've got the setup completely done. There are sometimes magic problems on the test that say write but do not integrate. Those are wonderful problems on the test. Those are kind of those sometimes become our favorites because they're so nice. All right, I'm going to probably use an extra line here to distribute this through. I could probably have done that in the last line and just swapped all my signs. All right, so from -2 to 4, we have, let's see, -x squared. I'm combining these together, so plus 2x. I'm combining those, I'm getting +8 dx. Looks a lot better than it did, right? So we're going to go ahead and do our integration step. So when I integrate, I get -x cubed over 3 plus 2x squared over 2 plus 8x from -2 to 4. I could cancel these 2's, so it's just an x squared. So officially, it would be -x cubed over 3 plus x squared plus 8x from -2 to 4. That would be the official. Here's what we're going to plug into. Okay. All right, so now I'm at the point where I'm just going to plug those numbers in. Okay. So let's come back up here. We've got negative, and then it's 4 cubed, but the negative is outside the cubed, not that it would matter, over 3, plus 4 squared plus 8 times 4. And then it's minus, and it's always a big parentheses anytime we do that. Okay, now we're going to put in the -2. So it's -2 cubed over 3 plus -2 squared plus 8 times -2. All right, let's keep going through the arithmetic. So -4 cubed would be 64. So -64 over 3 plus 16 plus 32, right? Minus, and the parentheses still. -2 cubed is -8. So I've got -8 over 3, which is going to be positive. -2 squared would be 4, and 8 times -2 is -16. I'm going to pause again, let you finish that piece. All right, I'm going to show you Mrs. Ballard's adding tricks right now, okay? What, because I haven't heard from you in a few minutes, so what do I need to do with this negative that's right here? What's instinct kick in and tell you to do? It's always good when we have some algebra that was like pre-algebra 1, right? It's distribute. I am going to choose to do that in this line and be a little sloppy about it. All right, so I'm actually distributing this in, meaning I'm going to swap all my signs. So I've got a negative, and a positive, and that's going to turn that positive. Now I'm going to combine like terms, just the way that it looks, okay? So the way that I do this is I will look for common, this is how I deal with the common denominators. So I'm not going to scale everything up to thirds until I really need to, because sometimes I get lucky and it simplifies, all right? So -64 and -8 is -72 thirds. And then let's see, when I add together 16 plus 32 minus 4 plus 16, I should get 60. And what do you know? 3 divides 72, doesn't it? Isn't that awesome? So -26 plus 60 is going to be 34. Now, Delta Math, I think that's where I pulled the homework from, is going to have you go all the way to the 34. Okay? College Board, free response, we would have stopped on this line right here. You stop as soon as you plug in, okay? Because you don't want to make an arithmetic mistake. There is a lot of room for arithmetic mistakes in there, right? Especially non-calculator, okay? So don't make the arithmetic mistake when you've got the opportunity, when you've got a free response. All right, not worth it. All right, give you a few more seconds on that one to write it down, and then I'm going to move to the, I think I might skip the next one, actually. We might come back to it if we've got enough time, but I think it's very similar to where we're at with these here. All right. X equals 3. Let's just write the setup, and then we're not going to do the we're not going to do the area of it. Okay. So let's practice the setup piece, and then if we have time, we can come back and actually do the integration. So it's telling me the regions in the first quadrant bounded by x squared plus 2. So that's kind of this red function right here. Okay, so that's the red one. And then the blue one is this horizontal line, y equals 1. This vertical line right here is that right there. It's one of the bounds, because what we're looking at, the region, is right here. And we know we stopped there because it says first quadrant. So if I'm going to set this up, which one is on the top? The x squared or the y equals 1? Can you guys tell me which one is on the top? All right, perfect. You guys are all recognizing the x squared. So I'm going to write my red one first. So x squared plus 2. And remember, the color really doesn't have anything to do with it. It could be the red first. It could be the blue. It doesn't matter. Okay, but it does matter. You have to make sure the top goes first. And then we're just going to subtract the bottom, which is a 1. And it seems weird because it's just a number, but that's what we do. And then, of course, there's a dx after it. Now, that brings us to our bounds. We actually have them without calculating. Can you guys tell me what the bounds are on this for that region? Think about the x values that it's between. We said what x value the green line is, right? And what x value is it starting at? So what do you guys think that the bounds are, or the numbers we're going to put on our integral? Tell me in the chat. Even if it's just a guess, tell me. Let's try it. All right, you guys are good. You are excellent. You are 100% right. It goes from 0 to 3. Perfect. All right. From there, it's not much different than what we did in the last one. You could integrate it by hand. Okay. So I'm not going to keep going on that one. We're just going to go with the setup so we can make sure we understand how to set these other ones up, because they are a little bit more challenging. We're going to at least do example 5, and then we might skip to 7. The ones in the homework look a little bit more like 7. But I couldn't find any like this one in Delta Math, but we still need to understand how to do it, because it is going to come up when we start talking about our free response problems, okay, in a few weeks here, towards the end of April. All right, so let's look in that left-hand column. So this moves on to, like, I think the lesson was split into 2, like it was 8.4 and 8.6 or something. This is going into the 8.6 part, where we've got 2 functions crossing, and notice there's 2 regions. Okay, sometimes the blue, no, I'm going to trace over these in a little bit better, blue and red. So do you see how sometimes the blue is on the top and the red is on the bottom? And then sometimes the red is on the top and the blue is on the bottom. So basically what I have to do is I have to set up 2 separate integrals. All right, and I just need to know where those 3 points of intersection are. It's not any more difficult, it's just a little bit more tedious. Okay, we got to be a little bit more careful. All right. So out in the left-hand column, our notes to remember what we are doing is that we sketch the graphs, if not already done for you, and shade the regions. No different than what we did before. This time we're going to find A, B, and C, such that when, so it's such and C and such. So maybe that means it could have a D because it could cross again, right? I could do something even crazier, couldn't I? Right, however many times it crosses, so A, B, C, D, E, however many times it crosses, and they want me to find regions, okay? When the graphs intersect and label A, B, C, D, and such. Or you could say etc. if you wanted. That could be another word there. Either one, you pick. All right, label the top equations and the bottom equations. Notice it's equations versus equation this time. Take the integral, and it's still going to be top minus bottom. So the integral of top minus bottom dx. And oh, that other little note's not there. We might need to add regions together. So let's add that in there. So you may need to add regions together. Okay, we'll leave it there for a minute, then we'll try one. Yep, I can go back up. Okay, let's take a look at example 5. Sorry, I skimmed the email, which was a mistake, right? So let the regions R and S be enclosed by the graph. So I have region R here, which I shouldn't have, and region S here. So there's my two regions. I've got my green region and my blue region, all right, or my tealy blue region, light blue. So f of x equals x cubed plus 4x minus x minus 1. And then g of x equals e to the x over 2 is shown in the figure above. Find the sum of the area of the regions R and S. All right. Is f of x, is this guy here, is that my blue equation, my blue graph, or my red graph? What do you guys think? So is that the blue graph or the red graph? All right, half the battle, you guys are doing really good. Half the battle is identifying what it belongs to, right? It is the red graph. If it was me, I'd probably write f of x on there and g of x on there. And let's see, this one is a calculator, it says right here. So we don't necessarily have to write out the actual equations. Okay, we're going to type those into our calculator, which hopefully you have going. You have it. I'm going to really quick start it while I'm still, if I don't click on it, then it takes forever to come up. All right, so I am looking at the green region right now. All right, so the green region is, I'm going to integrate, I know that. Sorry, my calculator is going to keep getting in the way now. All right, so I am looking at just this green region. Which one is on the top, F or G for the green region? Can you guys tell me which function is on the top, F or G? All right, perfect. It's the G, right? I'll minimize that for now. Close, minimize. All right, so I'm going to write g of x, and I'm able to do this because they gave me named functions. Unlike before, we had y equals, so we had to actually write out the function. So g of x, I'm going to do that in the, I'm going to color code for you though. It's the blue one, right? G of x. And then we're going to subtract the bottom function, which in that region is f of x. And then we're going to finish that off with dx. Then we are going to add that to the other region. And I don't know my bounds yet. I'm going to have to go in and do that on my calculator, all right? So maybe we'll label it a little differently here in just a second. So now in the blue region, the light blue region, which function is on the top? F of x or g of x? Can you tell me? F or g? All right, perfect. F is on top. So I'm going to start with f of x, and we're going to write minus the blue one, g of x, and then dx. All right, let's do a little bit of labeling on our graph, and then we're going to use our calculator's power to deal with this. Let's call this A, this B, and this C. The graders would not read that. What you would need to do if we're going to use this notation is we would have to say let A equal, B equal, and C equal. And then you could label this A to B and B to C. And this is pretty high sophisticated. Rather than using the numbers, we're kind of we're going to let some variables do the work for us. All right. The next thing we're going to do is go ahead and put these into our calculator. All right. So I'm going to go to my graphing calculator and I'm going to put these guys in. So, and I want to put them into, I'm going to go in the scratch pad and I go right for my graph. I'm going to go right into my graph and I'm going to start typing these in. So it's negative x to the third plus 4x squared minus x minus 1. We are adding the two things together. Let me go back and explain that really quick, okay? Because there's a difference here, okay? So this one is the green region, right? And within the green region, we have top minus bottom, okay? This is the blue region. Within the blue region, we have top minus bottom. But we are obligated to add the areas of the two regions together. Am I making more sense now, Casey? Okay, perfect. I'm glad you asked, okay? Because it's a sticking point, and we're gonna do something again similar when we hit the last part of this unit, the last few lessons, okay? So it's good to understand it really well here. Okay, we know that, let's see, what was the other thing I was thinking about here? Oh, you know, the other thing I was thinking about doing is you could make a note to yourself that you put this one into F1 and we're going to put this one into F2, but that's only a note to you. You don't use that in the problem, okay? All right, so I'm going to go back to my calculator, hit enter. Looks like what we got, right? It's the wrong color, but it looks like what we got. I'm going to grab this and take it out of the way because it's annoying to me. All right, and then I'm going to go into here and I am going to say E to the control. Oh, what happened? Something went really bad. I know what I did. I did the to the, it already had the to the, huh? It already had the exponent. Control divide, x over 2. And enter. Okay, so now we've got our regions. I really don't need to do any zooming or anything. What I need to do is figure out the bounds, okay? So I'm going to go to, okay, so what button do I have to push? What button do I need to push right now? Yes, Cynthia, it's also because it says find the sum. That's correct. All right, you're right. We got to go menu, analyze that graph, and we're going to go intersection. I'm going to go from the left to the right. There's one of my values. Oh, that's not what I meant to do. I wanted to just move it. There we go. All right. I double clicked. I'm going to hit Control C, Control V, Control Store, and I'm going to put that one in A, enter. And I would put that in the let A equal. Okay. All right, we're going to do the second one. Menu, analyze graph, intersection, to the left, to the right. I'm going to double click the value. Control C. Go back to my calculator page. Control V. Okay. And then Control var, and we're going to store it in B. Enter. All right, one more time, one more value here. Menu, analyze graph, intersection, to the left, to the right. There's my value. Click it twice. Maybe. There we go. Click it twice. Control C. And then I'm going to come back here, Control V. And then we're going to do Control var and store it in C. All right, I am going to write those down over here though, because we need to know those over here. So it was negative 0.5, oh, that's too light. Negative 0.52452. And then this one was 1.19070, or sorry, 707. And this one is 3.07760 or something like that, okay? Because if we have this and we have this, we're probably gonna, if this was like worth 2 or 3 points, if this was worth 3 or 4, we'd have like at least 2 points on that, maybe 3. Sometimes this part is worth like 4 points on the 9. All right, all we got to do now is plug it into our calculator exactly the way it looks. The big difference is the G is going to be F2, the F is going to be F1. So then it would go F2 or F1, F2. Okay. All right, so here we go. Shift plus, right? Shift plus. All right, and I'm going to go A to B. And then we're going to come here, we're going to go var. It was F2 first. So F2, I think that's right, isn't it? G was first, yeah, so that's F2. F2 of X minus, notice it adds parentheses for you, F1 of X dx. And then look at the size of the cursor. See how it's small, and then I just arrow and it becomes big. So I just push this arrow guy right here, it becomes big. Then I put a plus sign, because we're gonna do this all in one shot. All right. And then we're gonna do another shift plus. And then we're gonna go from B to C. And then we're gonna do var, and then it's the reverse this time. F1 was on the top, so var F1 of X minus var F2 of X dx. And then we're going to hit enter. I'm going to give you a minute there before we do the big reveal. Okay, let's hit the buttons. So 5.50149. Let's see if it'll let me copy it. There it is. Oh, look at all those extra decimals they gave me by doing the copy. And that's fine. You can write down as many as you want. You have to have at least 3. Okay? So it wasn't any harder than the last ones. It was just more tedious, right? It was a little bit longer. It was the same setups. Okay. In the interest of time, I'm going to go to one that's a little bit different than this one. Okay, because the little bit different ones might be what's on the homework, and I want you to be ready for that. Okay. So example 6, very similar, right? We've got the 2 regions. We're going to skip that one. Let's go to example 7. Okay. So in example 7, I still have 2 regions actually. It's just the way the regions are is a little bit different. Okay, it's not adding region R and region S. It's I have 2 different tops to region R, right? Up until whatever this value is right here. Come on. Okay. Now it's not letting me change my pen. Let's try this. Sometimes if I just do that, there we go. So up until here, it looks like it's the red function. And then from here on, I didn't do that in red, did I? Or is it? Oh, I guess it is red. All right, and then this is the blue function. So I need to integrate the red function to whatever this value is on the pink line. And then I need to integrate the blue one from the pink line to whatever that value is there. Okay. They didn't say this one is going to be calculator too. Okay, so this is a calculator problem. All right. So, is F the red one or the blue one? What do you guys think? So what's F? Is F the red or the blue? We're going to skip it entirely right now, Brianna. All right, F is in fact the red one. Okay, so that's the red one. And that would mean by default, this has to be the blue one. Good. All right, so I know that I have to integrate from something to something, square root of x dx. And that's really it, right? It's just that area under that curve. Because technically let's talk about the top minus the bottom. The top is here, isn't the bottom the x-axis? So if I subtracted the x-axis, it would just be like subtracting 0. So I kind of get away with not having to write the bottom. All right, then we're going to add that to the integral of the blue. So 9 minus x dx. We still need to figure out what all of these other values are. I need to know what a is there. It looks like 0, but I want to make sure. I need to know what b is, and I need to know what c is. Okay? Just based on those labels, what are the bounds or the limits on the integral for the red function? Can you guys tell me that in the chat? So what are my bounds on my red function? Based on the letters. What do you think? All right, nice work, everybody. A to B, okay, which means that the blue one has to be B to C. All right, perfect. All right, let's put it in our calculator. Let's see if we can get this thing integrated, okay? So, and the only thing we have to come back and write down are the A, B, C, and the answer. All right, I'm going to get rid of everything. All my hard work, Doc B. When we're on the AP test and we get closer to that, we'll stop using the scratch pad and we'll start using the documents piece, because then you don't have to delete it. So you can do problem 1 and then move on to problem 2, and if you have time, come back to problem 1 if you need to. So I'll teach you how to do that. We're not ready for that yet, though. But that way we don't have to delete all of our beautiful work, right? Control square root of x. I'm going to tab, and I'm going to do 9 minus x. All right, I want to calculate that point of intersection. So menu, analyze graph, intersection, to the left, to the right. So that's actually what we called our B value, right? So I'm going to store that one in B. I kind of did that one first. So Control C, come back to my calculator page, Control V, and then I go Control var, and this was B is what we wanted. At the same time, I'm going to write that down, 6.45862, 6.45862. All right, I do need to double check. It looks like 0 and 10. I don't always trust that, because sometimes it can be 0.0 something, 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 right? So I'm going to double check that by calculating zeros. So menu, analyze graph, I'm going to go zeros. And it's going to ask me which graph. I'm going to say this one. And it's very similar. Look, there it is. It popped up. It's very similar to the intersection, how we do it. I'm going to do it again. Menu, analyze graph 0. It's going to ask me which graph. So I'm going to click on the graph I want. Go to the left, go to the right. Oh, look. I would have read it as 10, but it was 9, wasn't it? So I'm glad I did that because we weren't counting, but the little 10 is like the label on the end of the graph, huh? So I'm glad we did that one. All right, so we know that A and B are going to be 9 and 0. So I could store that, or I could just use 0 and 9 and type it in. I'm going to choose to use 0 and 9 and type it in, but back here I do need to say, hey, we use 0 and 9. Or I need to switch this A to 0 and this C to 9. Your choice. Okay. All right. We're going to go back here and we're going to go Shift plus. We're going to go from 0 to B. And this was just the graph that was in F1 of X dx. And then we're going to go plus. But remember, I need the big plus. I'm going to arrow over big plus, Shift plus, B to 9. And then this was the second graph, var F2 of X dx. And we're going to hit enter. All right, so 14.174, so 14.1719. 14.1719. Okay. All right, I think that's probably going to give you enough to, this one, example 8's exactly the same. So here's what we're going to do. We're going to get rid of happy spring break. We're going to get rid of 8. We're going to get rid of 6. Okay, we've probably done enough to get you to where you need to be to do homework. Okay, to practice it a little bit. All right. All right. Give me a smiley face in the chat if you're ready to do if you're ready to go on spring break. That was the fastest thing you all put in the chat the whole period. Number